All right, we're back. Lesson 2 of Wednesday. My screen here. So we're still on rational expressions. We're looking at multiplying and dividing the rational expressions, which this part does get quite lengthy. So the same rules as multiplying and dividing regular fractions, but these involve variables. I mean, math is math, nothing really changes after that. So multiplication is relatively easy because it is quite similar to what you've been doing so far. So you just multiply the tops and you multiply the bottoms just like any regular fraction you would. So this one you would have 10x cubed y to the power of 4 times 3xy over 15x times 6y to the power of 4. So keep in mind that you multiply the coefficients. So 10 times 3 is 30. When you multiply the same variables, you add the exponents. So again, that should be reviewed to you. So you would have 3 plus that little invisible 1. So you would have x to the power of 4. There's a little invisible 1 on top of that y. So it would be 4 plus 3. So y to the power of 5. And that's it. From there, we have 15 times 6, which is 90. X, and then a y to the power of 4. Now, similar to what we did in earlier's lesson, so you're going to do 30 over 90. So that can be simplified to just 1 over 30. Or 1 over 3, sorry. So then, again, there's an invisible little 1 here. You're going to do x to the power of 4 minus 1, which is x to the power of 3. And then a y to the power of 5 minus 4, which is just y. So this 1 doesn't need to be there. We're going to write it a bit nicer. So x to the power of 3 times y over 3. That's it. You have to state your restrictions, which we did not do. So if we look here, we're looking at our denominators. X cannot be equal to 0 and y cannot be equal to 0. And that is it. Simple enough. I'm going to cancel this and move on to the next example, which is quite a bit lengthier. Okay, so first thing before we multiply is to factor. So if we look here, this can be factored by a common factor of 2m. So we're left with m squared minus 9, which then can be factored to 2m, m minus 3, m plus 3. Okay, so we're going to write this right here. So 2m, m minus 3, m plus 3 times, you factor that one. So you can factor out a common factor of 6. So we're left with n squared minus 5n minus 14. And then that would be just a simple trinomial. So two numbers that multiply to give you negative 14 and add to give you negative 5, which would be negative 7 and positive 2. Okay, so we are going to rewrite this one over here as well. It's best to factor it on the side, like on its own, and then put them back into the rational expression. I find it's a bit simpler. This guy here is a common factor, so n plus 2. So 3n plus 2. And then this guy also has a common factor of 8. So we're left with m plus 3. 8m plus 3. Okay, so they're all nicely factored, easy as pie. And then you can put them all as 1, which is where we have a little bit of a hard time. So 2m times 6 will do 12m. So m minus 3, m plus 3. It's an awful 3. n minus 7, n plus 2. And then you can do the 3 times 8, which will give you 24. M plus 3 and n plus 2. Okay, so this is where you're going to state your restrictions. So m cannot be equal to -3 and m cannot be equal to -2. Okay, so this can cancel this one out and that can cancel this one out. Now here, 12 and 24, we would be left with 1/2. 12 over 24 is 1/2 simplified. So this can stay like this. And then over 2. Okay, that is it. So I'm going to clear that. I'm actually going to pause this real quick, if I can. Okay, so we are back. I've got the little Zoom thing here, so I'm clearing this. And we are moving forward. So we have dividing rational expressions. So the same rules as dividing regular fractions, but these involve variables. So when you're dividing fractions, what you do is you flip your second fraction that's being divided. So when dividing, we must state restrictions for both the numerator and the denominator of the flipped fraction. So we're going to look at the example here, and then, well, there's 2 examples. Okay, so our first step is to factor. So this guy here, I need my pen. So this guy here is a complex trinomial. I'm not going to go through all the steps with you. So this one gives you 2x plus 5y to the power of 2. Again, if you don't know, let me know and we can go through it. This one, quite coincidentally, is a difference of squares. There's 2 terms. There's a subtraction in the middle, and both can be square rooted. So this gives us 2x minus 5y, 2x plus 5y. And our bottom little dude here is just a common factor of y. So we're left with 3x plus 2y. Okay, so we did the factoring. This can't be factored, obviously. Our restrictions now. So we need to do the restrictions of our second fraction. So that would be, yeah. So y can't be equal to 0. X cannot be equal to -2y over 3. I don't know why I put a 3. That's supposed to be an x. X cannot be equal to 5y plus or minus 5y over 2. Okay, and then this little guy would be the same. Okay, so we're going to write that as our simpler term before we do the multiplication of it. So we've got our 2x plus 5y to the power of 2 over 2x plus 5y. Divide by 2x minus 5y, 2x plus 5y, y times 3x plus 2y. So what we do with the division is we take our last fraction here, so the second one here, and you flip it. So you flip and it becomes a multiplication. It becomes easier like we had done previously. So for example, it becomes the power of 2 over 2x plus 5y. So this becomes a times, and our denominator becomes our numerator. That should be a 3. Okay. So this, keep in mind, no, it changed it for me here. It's not what I wanted. So keep in mind that this is the same thing as 2x plus 5y times 2x plus 5y. Okay, that's what that means. So we're canceling 1 out. We are left with 1. Actually, and it cancels out here as well. So it cancels both of those out. So I'm going to erase this guy here. Okay, so we are left with y 3x plus 2y over 2x minus 5y. Okay, and that is it. That's our answer for that one. So like I said, it is a long process. That's why I only put one question on your test. There is room for mistakes, unfortunately, because it's quite a big process. So just take your time with it. So I'm going to clear this and we'll do the last example. Okay, so our first terms here, there's nothing to factor. This is a simple trinomial, so two numbers that multiply to give you 12, but add to give you 7. So that would be 3 and 4. And then this guy is a difference of square. There's two terms, a subtraction in the middle, and they both could be square rooted. So we have plus 2x minus 2. So we rewrite it like this, put a multiplication there. Our denominator becomes a numerator. We flip it. And that becomes the denominator. Okay. This can cancel that out. That can cancel this out. And we are left with x plus 2 over x plus 4. Now, one thing that we did forget to do is the restrictions. So we take the restrictions of this guy. So x cannot be equal to 2. We take all of these. Okay, so x cannot be equal to negative 2. X cannot be equal to negative 3. And x cannot be equal to negative 4. And those are our answers. Good luck.